We'll move on to our last presentation. We have Valerie Pianin and Elizabeth Marra Viehdorfer from the US Census Bureau, and they are presenting Improving Nowcasts of International Trade Data for the Index of Economic Activity. And I'm a little biased on this one since I work on this team, but excited to see what you guys have for us today. Liz and Valerie, are you able to pull up your slides?
Oh, sorry, I was on mute. I'm pulling up now.
There you go.
Should be able to see the slide, I believe.
Yep.
Okay. Just adjust my view here. Okay. Thank you, Rebecca. As she said, we will be presenting on improving nowcasts of international trade data for the Index of Economic Activity. So the Index of Economic Activity, or the IDEA, as we like to call it, is an aggregation of 15 of the Census Bureau's primary economic indicators. We calculate the index by first computing the growth rates for each of the 15 seasonally adjusted component series. We do this by taking the month-to-month differences of the log series. You can see the formula there under the second bullet. And then we rescale these growth rates to have mean 0 and variance 1. After that, we apply principal component analysis to the 15 rescaled growth rates series, and we use the first principal component as weights. So for example, if we have variables x1 and x2, we find weights W1 and W2 using PCA, and then we would calculate the index as W1 times x1 plus W2 times x2. So on this slide, I have a little refresher on how PCA works. First, the correlation matrix of the 15 data series is used to calculate the eigenvalues and eigenvectors. The elements of the eigenvector corresponding to the largest eigenvalue define the weights for the index. Using these weights, we compute the weighted linear combination of the 15 data series, which, thanks to the properties of PCA, has maximum variance over all linear combinations whose squared weights sum to 1. So just to give you an idea of what the 15 data series are, I've listed them here in the left-hand column. I've ranked them by their weights, which are listed on the far right. And I want to point out at the top of the list, we have exports of goods and services. And third there on the list is imports of goods and services. We will be focusing on these two time series later, but I wanted to point them out. They're the first and third highest weighted. So as you can imagine, combining 15 different economic data series from 5 different survey areas into a meaningful index can present a lot of challenges. I'm not going to go over number 1 on the slide here today. I just don't have time. But for number 2, this is what the rest of our presentation will focus on. The challenge here is the fact that these indicators are published at different dates during the month. And in fact, these dates can change from month to month, which can cause a change in the order of the release dates between months. The methodology that our team has developed to account for these moving dates is called nowcasting. So nowcasting is a projection based on past time series and present cross-sectional data. So in our case, the past time series would be the 15 historic economic indicators going back to August 2004. And the present cross-sectional data would be the indicators that have been published for a month on any given day. We use a fitted order 1 vector autoregression, or a VAR1 model, to predict or nowcast the unreleased indicators. In this multivariate model, we included the same 15 data series that we also used in the PCA analysis. Then, once we have the nowcasts, we combine those with the published data and the PCA weights that we discussed earlier. And this gives us an early estimate of the index for the month. Perhaps it would be easier if I walked through an example of how we do this nowcasting. So here I'm going to go through an example from July of 2023. I'm only presenting a subset of the 15 series that we actually nowcasted, so as not to overcrowd the slide. And I'll go through 3 business days in the month of August, where on each day, a different indicator is published. So the green bars represent published data, and the yellow bars represent nowcasted values, so predicted values. On August 11th, we can see that business formation statistics right here at the top was released for the month of July, while retail sales here and new residential construction, these down here, were unreleased. There's 3 time series from the new residential construction survey. So for those last 4 series, we now casted those values using the VAR1 model. At the bottom of the graphic, you can see the estimate for the index on August 11th is 0.11. This index estimate is based on 1 published number, so business formations, and 14 nowcasted numbers. On August 15th, we can see that the published value for retail sales was released. So right here, it went from yellow to green, and the rest remain unpublished. So again, we estimated the index. That value changed to 0.2. And then on August 16th, new residential construction was released, and all 3 of those time series were updated with published data. The value of the index again changed to 0.14. Here is a closer look at the graph of the index. This graph goes back to August 2004. One of the nice features is that you can hover over any point on the line to see the estimate of the index for that month. I've done that here for August 2011. The index was 0.3. One thing to note is that this is a process control chart. It signifies whether economic activity is within a normal range, which we have represented on the graph by darker blue bands. You can see the index is clearly capturing the change in economic activity for the Great Recession back in 2008 and 2009. It also captured the COVID-19 recession in early 2020. Those areas are highlighted with those vertical gray bands. So let's talk a little bit more about what causes movement in the index. So we can't control the economy, right? The index is going to go where it may. But specifically, I want to focus on a few of the series from November of 2022. So you can see there I have the 15 series listed right here, along with and they're ranked by their PCA weights in this column here. I've highlighted the 3 series that had the largest changes that month. And on the graph there, you can see that the index dropped from negative 0.08 in October to negative 1.47 in November. So in this example, we would have been really concerned with accurately nowcasting those 3 time series with the largest changes. And based on the weights, we would have been more concerned about the accuracy of the nowcast for imports of goods and services than for the other 2 series. As I've mentioned before, release dates can change from month to month, and even the order in which these series are released can change. However, we've found that pretty consistently international trade, so imports and exports of goods and services, is one of the last indicators to be released. And often when there are large swings in the trade data, it's been a challenge to nowcast them. So in researching ways to address this, we first considered the idea of using the advanced trade estimates in the index calculations. And what I mean by that is, for many of our monthly indicators at Census, we produce advanced estimates. So for example, we have advanced retail sales released 1 month, and then the next month, as we get more data in, we release the full retail sales. For the weighted index calculation, we use these advanced retail sales estimates and then replace them with the full retail sales estimates once they're released. Now, international trade does produce advanced estimates of imports and exports. However, they're not a direct comparison to the full trade estimates in the way they are for other surveys. And let me go over why that is on the next slide here. First, advanced estimates are for goods only, while the full estimates for international trade are for goods and services. And then second, advanced estimates are produced on a census basis, while the full estimates are produced on a balance of payments basis. I don't have time to discuss the nuances of this difference, but it suffices to know that for both of these reasons, we can't use advanced trade data in the same way that we use advanced data from other surveys, so like we do for retail. So even with this issue in mind, we thought, well, there must be some way, right, that we could still use this data. And the first thing in our research we did was we wanted to know whether or not advanced trade growth rates were predictive of full trade growth rates. So we began by running a few different regression models on the seasonally adjusted growth rates, and we compared the prediction error between the models. And we were hoping to see a reduction in prediction error. So on this slide, I have the 4 models that we ran. The first was simply to use advanced trade as a forecast of full trade. We calculated the root mean square difference there for the error to use for comparison. The second model we ran was an autoregressive model of the full export or full import growth rates, and we added one advanced growth rate series as a regressor. So for example, if we were running an AR model for full exports, we would add advanced exports as a regressor. We did the same for full imports, adding advanced imports as a regressor. The third model that we ran was an autoregressive model, again, of full imports or full exports, the growth rates that is, with advanced growth rates for both imports and exports included as regressors. So this time, for example, if we would run an AR model for full exports, we added both advanced exports and advanced imports as regressors. Same thing for full imports. And then the fourth model is the normal linear regression, where we regress the full growth rates on the advanced growth rates. Let's take a look at some of the results here. So notice in the first column here, I have an autoregressive model of the full growth rates with no other regressors included. This can be considered the baseline for comparison to the other models. So that's this column here. Whoops. Since it contains no advanced data in it. Then the next column shows the RMSD for the model where we simply use advanced data as a forecast of the full data. You can see that the error for both imports and exports is reduced by more than half. The 2 columns after that show the AR models, including either one or both advanced estimates as regressors. Notice again that the error is reduced by close to half. And then finally, in the last column, we have the simple linear regression. We didn't see much change there compared to the 2 AR models in the middle here. Basically, this told us that the benefit here really was from including the advanced trade data in the model and not necessarily using an AR model versus a linear regression. So after running these models, we concluded advanced trade growth rates are highly predictive of full trade. Now, knowing this, we wanted to figure out a way that we could use advanced trade to improve the index without using the advanced data in the traditional way that we do for other surveys. And this is where I will hand the presentation over to my colleague, Valerie.
Thank you. So these are the options we considered. 1, remove full trade from calculations and instead use advanced trade to calculate the index. This would use 15 time series. 2, use advanced trade in addition to full trade to calculate the index. This increases the number of series to 17. 3, add advanced trade to the nowcasting, but only use full trade for the index calculation. The nowcasting now involves 17 series, but only the original 15 are used to calculate the index. And last, keep the index as it is with no advanced trade numbers. Option 1, replacing full trade with the advanced trade numbers. This method would be easy to implement, make interpretable sense, and we get the advanced numbers earlier in the month. The con is that we wouldn't be including the imports, exports, which are in the full numbers. As Liz mentioned, the advanced estimates for international trade are not a direct comparison. Option 2, add advanced trade numbers to the index calculations. The pro, it uses advanced trade data that we have available. The con, there is the difference between the advanced trade and full trade. While full trade is the imports, exports of goods and services, advanced trade is imports, exports of goods. No trade of service are included. Option 3, add the advanced trade series to the fitting of the nowcast model. Pros, this method uses all of the available data. And advanced trade is predictive of a full trade, so it will help us get better nowcasts for international trade. Cons, it would divert from the conceptual consistency that underlies the index and that is realized in the historical numbers. It could also negatively affect the nowcasts of other indicators. Last, option 4, make no changes and keep the index as it is. This would be less work for us, but it doesn't take advantage of the advanced trade data that we have available. Next, we tested the options. These methods were coded and run along with our daily production programs. So option 1, advanced trade replacing full trade. We expected the growth rates for full and advanced trade to be similar, but when we investigated, the difference was greater than anticipated. We also found that the use of advanced trade has a noticeable effect on the index value and weights. We want to predict the final index number earlier in the month while maintaining the original setup of the index. So we don't want to significantly alter the index numbers. The table here compares the year's monthly index values for our current production method and option 1. And we can see the difference in index values ranges from 0.05 to 0.38 with an average difference of 0.1. Next, option 2.
I know you're good.
Add advanced trade to the index calculations. This results in the trade series weighing more heavily than we want, especially since the 4 trade series are representing too much of the same thing. This method also has a noticeable effect on the index, which we don't want. This table here compares the weights for our current production method and option 2. The series are sorted with weights greatest to smallest. The advanced and full trade series are both in bold. We see all 4 trade series are on top with the greatest weights. Option 3, add advanced trade for modeling and nowcasting. This gives us a better nowcast of trade earlier, which gives us a better estimate of the index earlier. There is less volatility in the index value throughout the month, and it doesn't affect the final monthly index value. The graph presents the percentage difference between the nowcast and the published trade number for full trade exports in March 2024. The goal is for the percent difference to be as close to 0 as early as possible in the month. The orange represents the nowcast with advanced trade, and the blue line is without advanced trade. On day 11, the advanced trade is published, and the nowcast with advanced trade, the orange line, jumps down to just below 0%. We get a better nowcast 5 days before the full trade numbers are released on day 16. This graph is for the exports, but the imports graph is very similar. There are also months where the nowcasts are negatively affected, but these are typically series with low weights or series that are published early in the month that we determine to be acceptable. Here we are comparing the nowcasting variance of the current production method and option 3. In the first row, we can see that the index nowcasting variance is lower for option 3 when the advanced trade is included. On the day this was run, 5 series were yet to be published. So we have the nowcasting variance for these, construction spending, manufacturing new orders, international trade imports and exports, manufacturing inventories. And for each series, the index nowcasting variance is lower for option 3. We see an especially big impact on the international trade. Comparing the index values with and without advanced trade in the nowcasting model, the graph has the index values for each day in the March production month. The goal here is to reach the final index value as early as possible in the month. Again, notice that on day 11, the orange line, which includes the advanced trade in nowcasting, jumps down to the final index value, while it takes some time until day 16 for the blue line to reach that same value. And taking all this into consideration, our final decision was option 3, add advanced trade series to the nowcast model. While we have not yet implemented this change in production, we continue to monitor how this affects the index. This research is promising, and we hope to implement it within the next year.
Great, excellent time.
Thank you.
So we're right at 4:01, so we're slightly over, but if anyone has questions, please feel free. So I work on this team, so I know a lot of these answers already. But are there other series that could potentially include the same thing? So I know there's some advanced manufacturing and full manufacturing. Do we take that into account with advanced?
You're asking if we've looked into these other series?
No, if we
Yeah.
if we take advanced into account with the other series, which I believe we do.
Oh, okay. Yeah, I actually wasn't. I know we did it for retail. I assumed we did it for all of them.
Yes.
So yeah. So yes. Okay.
Yeah. So this is really the only series that has this limitation. Well, if we have no other questions, thank you to all of our presenters for joining the session and sharing all of your research. Really appreciate it. And I believe everyone gave their contact info. So if you do have follow-up questions, you can reach out to everyone.